Hello. Okay, so science fiction. We often come across the concept of silicon based life forms. So I wanted to discuss them. The possibility. Well, not necessarily the possibility, but again, this is going to be another speculative how would this work rather than the possibility of them actually existing. So, why silicon? Very abundant, on Earth at least. Just as carbon is very abundant, so that's one reason we have carbon based. But that's not really the real reason people speculated about it. Now, this isn't something science fiction writers just made up, silicon based. This is something scientists actually speculated at about one time. So, carbon. Go back to your old chemistry lessons. We have the concept of valence. Valence is how many electron bonds a given element can make. And it's based basically on how many electrons are in the outer ring or outer orbit, outermost orbit of the atom for that element. Okay, makes sense. Now, early chemistry, we learned electrons orbit the nucleus, and we, it was taught. The way it was taught, you would get the mental image of, basically a solar system type setup. Take a more advanced chemistry class, high school level, and you get the idea of each orbit actually has multiple electrons in it. And the farther out you go, the bigger the orbits, the more electrons it can hold. So larger, higher atomic number, the more orbits we expect. Go a little further, and we find out that these aren't nice, neat orbits. There are actually suborbits to them. So this orbit can hold so many electrons, and they are arranged in this way between suborbits. More to the fact, we find out that the orbits can overlap now. So we got one with 2 orbits going, and we got one with 4 orbits, but the innermost one on the outer band might be closer to the nucleus than the outermost one on the inner band. And that affects valence. How can we share electrons? And when we have our orbits overlapping, that'll start to affect it. And then we get into things like, even further, we find out that it's not really nice little orbits, it's really probability clouds of where the electron is. And we get all sorts of weird shapes going on where the electron may be. And that further complicates things. And why am I going through all this? So, carbon has a valence of 4. And so some places will have a valence listed as positive or negative. And that's whether the element in question is sharing an electron, or whether it's providing the electron that's being shared, or whether it's got a gap that the other atom is giving. With 4, you can either give or take electrons. That immediately makes carbon more flexible. You can combine with different combinations. You can combine with 4 elements which have a valence of 1. You can combine with 2 elements that each have valence of 2, or one which has 1 and one which has 3. You can do sorts of things. You can combine with another carbon and have something with a valence of 4. So you can start to do all sorts of weird tricks. And then plus with this, without this, it's simple enough you don't have this overlapping going on. So you don't have other interference coming in. So carbon is the most flexible for sharing electrons and making chemical bonds. And so biochemistry, you're going to take organic chemistry is basically chemistry specifically dealing with carbon, and because it's big in life, and it gets its own class actually, even though you still have to learn other forms of biochemistry. So that is one thing going on here. Now silicon is the next most flexible. It's also got a valence of 4, but again, it's a little heavier. It's got more electrons going around it. They're orbital, more interference between orbits or bands, or I don't know how you would describe it exactly, but it doesn't share as much or as well as carbon. And that's possibly one reason why we don't have silicon-based life, is because it's just not flexible enough. But because it is the next most flexible element, we speculate that about the possibility of silicon-based life. So that's that part of it. Why don't we talk about oxygen-based life? Because oxygen's not a very flexible element. Okay, so looking at silicon-based life, and here's where we start to speculate now. Okay, first off, we would have to invent an entirely new silicon-based biochemistry. Everything, or almost everything we do with carbon-based life, all our enzymes, everything has carbon in it. And it's all based on, how well can it trade off with, other enzymes and, chemical reactions going on. So it's not enough just to have two chemicals coming together. We want two carbon-based chemicals coming together. And to do that, they both have to be somewhat flexible, and thanks to carbon being flexible, we can do this. So for silicon-based life, we would have to do the same thing. We would need two silicon-based chemicals coming together, both being flexible enough to interact with each other and trade off, and however enzymes interact, trading off atoms, breaking each other apart, whatever. It's I'm really oversimplifying stuff here. But the point being, we would need an entirely silicon-based biochemistry system in order for it to work. Now, life. What is life? So there are definitions. People try to... the ability to reproduce is considered one of the things which makes something living or not. That's been bent a little bit because viruses don't reproduce on their own. And so for a while they weren't considered life, and then it's considered, well, they can force another cell to reproduce them for them. And so people went back and forth for a while. Is a virus alive or not? And now we accept it as being alive. For a time we didn't. So stuff has to be able to reproduce. Some people say motion. That's questionable. Plants don't walk around, but they do grow. So growth would be one some people put out there. Reproduction is the main one, but there are some people who have other standards they put out there as well. So our silicon-based life should be able to grow, at least, we would think. Well, it's got to reproduce somehow. That means growth. I mean, even mitosis, a cell splits apart, becomes two new cells. In order to do that, it has to grow first. It doesn't just make two cells half the size and they split into two cells 1/4 the size and keep going out. It's one cell ingests a lot of material, grows, duplicates itself internally, then splits into two cells. And they both might be a little smaller than the original cell, and then they each have to eat and grow, or it might be it grows to twice its size and then splits into two cells which are both its original size. It depends on the cell. That's mitosizing. So similarly, if our carbon-based life is going to be reproducing somehow, it's got to be able to grow somehow. Whether it is splitting apart on its own or whether it is forming a baby inside itself and then it's got to nourish it and then that baby has to grow to become an adult. Somehow it has to grow. For this, it needs to eat somehow. Now, we eat carbon-based stuff in order to absorb carbon and grow. We need other nutrients, but again, carbon is very important to our growth and to our diet. So our silicon-based life form should need silicon to grow. Makes sense? So what's it eating? It can either take stuff directly from the planet, but then the planet's eventually going to wear out. Or it's going to excrete waste, and then that waste has to somehow reconvert into a form that it can eat again. Or somehow there has to be a system. Or there can be other carbon-based life forms that it feeds on. So would we, in our as we create our carbon-based life form, we have to consider others? Are there the equivalent of vegetable carbon or silicon-based life forms? Not carbon. Sorry about that. Are there going to be the equivalent of vegetable and animal silicon-based life forms? Would they have the equivalent of funguses? Would they have diseases? Micro silicon based life forms. Because again, bacteria and viruses work on us because they are partially carbon based also. So microorganisms in a silicon based world would also have to be carbon based, you would think. Again, this is all speculation, I could be wrong, but it makes sense. So now we're getting into, it's not enough just to make one silicon-based life form, we have to make a silicon-based ecosystem. If we do have plants, then do they have some sort of photosynthetic reaction? Because yes, plants do take nutrients from the soil, but that's not their sole source. And that's basically photosynthesis fuels everything. We can't grow plants without sunlight. And so they all die, and all the animals die, and everything ends up going away. So our carbon-based system should also probably have an outside energy force. Doesn't necessarily have to be sunlight. Could be some sort of radiation. Don't know. So there we are. Star Trek, the Horda, the original series. That was sort of the best attempt anyone's made that I've seen of making a silicon-based life form. And even then, it was just, we know that it eats rocks. And, it laid eggs, which were sort of silicon nodules. The rest of its biology we knew nothing about. Was just a quick and dirty, here's how it works. But even then, they went into more detail than any other silicon-based life form I've seen listed. There is the old Universal picture, the monolith monsters, which I like. All it is they absorb silicon from the ground, they grow into large towers, fall over, break up, then the pieces absorb silicon from the ground, until they basically spread out and cover the entire planet. Even with them, it took a catalyst. They were inert rocks until they got wet. And they came from another planet, basically. A meteorite fell, and the monolith monster babies, I guess, were a part of it. And so they're sort of a cheesy movie, but at the same time, it does sort of go back into the whole bio ecosystem if you have one single thing just eating, growing, falling apart, eating, growing, falling apart, that's its life cycle. Eventually, it's going to just completely consume the planet it's on, and its only choice is to float around as a meteor and land on another planet, and hope that that planet has water on it, because again, you needed water to catalyze to start the whole reaction. So interesting, but not as good as the Horta from Star Trek. Although they did, again, went through a life cycle, which was interesting. And they didn't go through any of the biochemistry of how this actually works and how the thing actually grows or how water actually causes it to activate. There we have it. Two examples from science fiction of silicon-based life form, and the only two I've ever seen which actually give us any kind of, rational thought into it. And then my speculation on why we don't get more of it and what it would take to actually make a silicon based life form. That's it. Have a nice day.